Hey guys, what's up? So starting from today, I've decided to work through the Project Euler questions. So if you don't know what Project Euler is, it's basically a website that has a lot of good math questions on it, which are intended to be solved using programs. So I'll just be going through these and I'll post videos of me working through them in batches. As they get harder, I might be doing less questions in each video. And yeah, so let's get started. Okay, so this one we're just simply summing up all the numbers that are either divisible by 3 or divisible by 5 under 1000. Okay, so this just pretty much skips a number if it's not divisible by 3 or 5, and if it is, then we just add it to the sum. Okay, so that should be fine. Cool. Okay, next question. Okay, so it looks like we're going to have to generate the Fibonacci sequence and find the sum of all the numbers that don't exceed 4 million and are even. Okay. Okay, so I'm just going to initialize the first two values of the Fibonacci sequence. I think it was 4 million. Yeah, 4 million. And then now that we actually have generated numbers, I'm going to go through them. So, and if it's odd, then we skip it. Otherwise, we add it to the sum. So that should be our answer. Cool. Okay. Third one. Largest prime factor. Okay, so it's exactly what it sounds like. It's just the largest prime factor. Okay. Okay. Okay, so I guess we should make an is prime method. Square root of skip it. Okay. And let's copy this number. And now we'll say while is prime of n equals -1. So while the number, or is not equal to -1, sorry. And then we're going to, and then we have to make an answer. So let's initially set the answer to be like, let's say 1. And we'll say set max between ans and res. And then we're going to decrease the number by whatever factor we got. Okay, this should be fine. That should be our answer. All right. So we're trying to find numbers that are palindromes, that are 2 digits. Oh, no. Okay, so they should be the product of 2 3-digit numbers. Okay, so we just brute force this, I think. And we're going to go through each one. So oops. So basically, if t equals s, then it's a palindrome, and if it is a palindrome, then let's increase the maximum. So, oops. Okay, so that just updates it pretty quickly, and this might take a while just because of strings, but it looks like that's our answer. All right, next question. Okay, so this is just the GCD of every single number. So let's make a GCD method, or an LCM method, sorry. This is something pretty useful. You can get the LCM by using the GCD. And, okay, so okay, that's pretty straightforward. Not much to that one. Alrighty. Next one. The sum of the squares. Okay, and the square of the sums. Find the difference. So they just want you to find the difference. Okay, that's pretty easy, I guess. From 1 to 100. Okay, another pretty straightforward one. Okay. All right, next one. Okay, we're just trying to find the ith prime number. I is pretty small, 10,000, so we should be able to just go ahead and brute force this one out and just check every single number. So So let's say 0 num equals 2 and oops. Okay. Num plus plus if is prime of num counter plus plus if the counter is 3 1 print line num. Okay, so in this one I'm literally just going through and finding the prime number. Not much to that question. I'm surprised to see that the 10,000th prime number is this small. I think it'd be bigger than this. All right, eighth one. Oh, this looks interesting. The 4 adjacent digits. Okay, so we want to find consecutive digits and multiply them together. Okay, so this is also just pretty simple to do. Okay, let's copy this over. I'm going to put it into Chrome first for the formatting. Okay. Next, let's say, okay, if it's 13 long num minus 12, and let's also make an answer variable. I plus 13 prod times equal. Okay, we need to convert a num of j. Let's do, I think this will work for string, for character conversion to an int. I think that's fine. And then we say oops. Okay, so I literally just went through and I took every, 13. Let's see what happened. Oops. This should just be, yeah, okay. So that should be my answer. Alrighty. Moving on to number 9, Pythagorean triplet. 1 for which a plus b plus c equals 1000. So obviously n cubed is too slow, so we'll just calculate a and b with n squared, and then by logic we'll just get c. Okay, so if it's over 1000, then it's not going to be possible. But if it isn't, then whatever that third number is going to be equal to 1000 minus the first two numbers. So this condition is met. And then we just say if I j equals k times k, print line I times j times k. Okay. cool. And number 10, summation of primes. Okay, I think this is just another brute force. This might take a little bit longer, but it should still run in like under 10 to 15 seconds, so I think we're fine. And I guess we should make the isPrime method again. I should probably keep this function. It seems to be a recurring theme in these questions. Oops, okay. Below 2 million. One, two. So for this one, I also just go through every single prime and I multiply together, or I add them together. Pretty simple. This might take a while to run because it's going to be square root of n times n, which is relatively big, but it shouldn't take too long to run. All right. Ooh, it's incorrect. What did I do? Oh, I counted 1 as a prime number. Okay, so my previous answer, let's subtract 1. I think that should be correct because previously this loop starts at 1, so I was counting 1 as a prime number. Yep, there we go. And there we go. That is 10 problems solved right there.